All right, 4-6. We have polynomial inequalities and rational inequalities. Let me explain the difference between the two. Polynomials, those are those nice, like x to the fourth plus x cubed plus x squared. Instead of equations, now we're looking at inequalities, which means there's shading involved, there's more than one answer, there's an infinite set of answers, and you have to just describe where they are, because you can't list them all. Then there's also rational inequalities, which means the fraction functions, but it's an inequality. The rational inequalities are not on the exam, so they are not going to be in this lesson. Yay! So go to the first slide. We just need to know how to do polynomial inequalities. There's two ways to do it. I'm going to show you on this slide the algebraic way, because some people just like good old-fashioned algebra. And then on the next slide, I'm going to show you, I'm going to show you two slides with algebraic, and then the last two slides, I'm going to show you how to use the calculator, okay? So look at this example right here. I went ahead and copied the graph for you so you didn't have to sketch it because I wanted it to be accurate. So just ignore the graph for a second. This is saying x squared minus 4x minus 5 is greater than 0, right? The first thing that you need to remind yourself when you're doing any type of inequality is the sign right here is telling you whether it's an open or closed circle, which means it's telling you whether it's a bracket or a parenthesis, right? Parentheses. So make sure to make a note that this means open because there's no line underneath or equal to. So when we go and write our final answer, we're going to use parentheses. So watch out for that because you can have the right answer, but if you use the wrong type of enclosure, it's going to mark it wrong. So that makes a difference. So I always, when I'm starting this, I make a note, open, and then I make a note as to what I need to remember at the end. That's a good old-fashioned quadratic, right? The technique for solving inequalities is you solve like it's an equation to find what's called your critical points. Your critical points are where the solution set either ends or begins, and then you just shade. You have to test sections and shade to see where your answer is. So we're going to pretend like this is just an equation. We're going to say this is x squared minus 4x minus 5 equals 0. We're going to solve it by factoring. So you factor it real quick. Factors of negative 5 that add up to negative 4. What'd you get? Negative 5 and positive 1. And because a is 1, we can go straight to, when we go to our parentheses, we don't have to factor a GCF out, right? We're done. So 1x, negative 5, and 1x, what'd you say, positive 1? And so now the zeros, pull the solutions out of those. So the 0 out of this would be 5, and the 0 out of this would be negative 1. Okay, so these are your critical points. Meaning it is critical that you have an open circle on these numbers because this is where the solution set is either changing, like it's going in one direction or it's going in this direction. But these points are where it's critical because it's switching from part of the solution to not part of the solution. So then the idea is you draw a number line, you plot these numbers on your critical on your number line as your critical points. Put them in the correct order, obviously. So -1, 5. We have open circles to remind me that I'm doing parentheses. And it's a good old-fashioned test a number from each section and then see where it's true. And where it's true, you shade. So I like to pick easy numbers. You have to have a number sense here. So if I was going left of -1, the next number would be -2. If I was picking a number between -1 and 5, what would be really easy? 0. And then above 5 would be 6. So we're going to test x equals -2, x equals 0, and x equals 6.
Do you know how to make my x be an x not like that?
Change your mode. You're in polar mode. Hit mode and then go to function mode. Now 0 is really easy to test. You can come up here. By the way, you are testing the original. You don't test the equation. Don't test the equation. Go back to the original. So plug 0 in the original. That disappears, that disappears. You're left with -5 is greater than 0. -5 is greater than 0. Is that true or false? That's false. Right? Which means above 0, I'm going to make a note to myself, like, I am not shading there, because that was false. Or if you don't want to put an X, because that makes you think of the X, you can put an F to say false. Now we're going to test -2. You plug -2 in. 12 minus 5 is 7. So you end up with 7 is greater than 0. True or false? That's true. So I'm going to put a check mark here and I'm going to shade. Now test 6. -6 minus 24. 12 minus 5, 7. So 7 is greater than 0. We already said that that is true, so 6 was true. That's your solution set. Now, in my math lab, they want you to put it in interval notation, which is why this little number line is really helpful. Because now you know, okay, this way was -infinity, this way is infinity. So now I'm going to write this from left to right. I've got -infinity up to that critical point, -1, parentheses, union with 5 to infinity. And beyond. Now I'm going to change colors here and I don't want to do change to green. Go to your graph. This is the shortcut. I'm going to go ahead and start introducing it to you. If I would have just gone to my calculator, entered it in y equals, and looked at the graph, go back to the inequality. Don't focus on the numbers and the variables so much as focus on the graph. Just use the phrase, the graph. Right? Okay, so where is the graph, read it, greater than 0? That translates to where is the graph. Since it says greater than 0, that would mean above the x-axis. Where's the graph above the x-axis? So you look at the picture and you say to yourself, well, above the x-axis would be here, right? And here. Yes? And you might think, well, how in the world am I supposed to get that out of looking at the graph? Well, if you look at where the graph is based on the inequality, in this case, above the x-axis, you would tell yourself, well, since it's from here going up, it's also going where? As it's going up. It's going out, which means the x-axis in this direction is part of the solution set. Then come over to the other side. Right here, as it's going up, it's also going out. So right here, in this direction, is the other part of the solution set. And then you just read that to yourself. That's negative infinity up to negative 1 with a parentheses, union with 5 parentheses to infinity. So that directly matches this. Now, what if the graph was not pretty and you didn't know it was negative 1 or 5? Then you would have to do that second calc, find the 0, and get the 0 there. But the calculator would tell you what the 0 is, and then you would know, okay, so it's coming from negative infinity to that. And then here it's, you do second calc, find the 0, it's going from that to infinity. Now that was because it said, where is it greater than 0? What if it had said less than 0?
Below it.
Then you're highlighting the part that would be below it, and in this case it would be from negative 1 to 5, and that's the only answer, because that's the only portion below the x-axis.
So if it's always greater than 0, it's up, and if it's always 0.
Every single time. Which is why I use the graphing method, because I can solve it in like 2 minutes by the graphing method than the algebra method. Now, if I'm nervous about my graphing method answer, I could go and do the algebra, and they should match. But if you're nervous about the algebra, understand how to find it in the graph.
Do you have to do
Algebra? No.
Can you just do like factoring and hit the 5 and then the 1?
You could, and then you could come here and you could say to yourself, okay, I know that's negative 1, I know that's 5. Where's the graph above it? And then you could go straight to the answer. All right. Let's try another one. Example 2. Now this one's slightly different. What do you notice? You got stuff on each side, right? You can't do this technique, the graphing technique, if you've got stuff on each side. Because this is no longer where's the graph above or below the x-axis. Now it's where is this graph, in this case, below this graph. We don't want to do that, okay? You can do that, but I personally like to just go by the x-axis, because then I can clearly see, it's like an iceberg. Right ahead, sorry, I'm obsessed with Titanic, but I can see where the graph is above the x-axis or below the x-axis instead of trying to do above this graph. I don't do that. So subtract everything over. Subtract it all over. Manipulate it so that it is inequality sign 0. Move it all to the left so that the 0 is on the right, and then the calculator trick works, or the graph trick works. So I'm going to subtract this to its like term. I'm going to subtract this to its like term. And now I'm going to tell myself, so where's the graph less than or equal to 0. What does the or equal to mean I'm going to use? I'm going to use brackets. It's closed, so be careful when you go to write your answer on your critical values. You've got to put brackets. Now, this particular one factor is really short and sweet, so let's just factor it. Let's don't get too lazy and rely on the calculator every time. If it's something that will factor, factor it. Because then, when you go to the calculator, you can confirm your zeros, instead of just relying on the calculator. Factors of -8 that add up to 2. -4 or 4 and -2, right? Yeah. And a is 1, so it'd be 1x plus 4, 1x minus 2. There's no GCF to come out of it. We are pretending it's a equation for a second, so we can solve it. We're just pretending. All right, what 0 comes out of this? And then this one. So those are my critical points. Now I can go to my calculator. Y equals, you want to enter, this is why you really have to make sure you did subtract or add things to the other side correctly. But you want to enter your new one that has 0 on the other side. Otherwise this doesn't work. Alright, and I'm going to zoom 6 it. Then I can confirm it's definitely crossing at -4, it's definitely crossing at 2. Now remind yourself what the shortcut question is. Where is the graph? It says less than, so that would mean look where? Below the x-axis. So below the x-axis is going to be this portion here, right? Which means now you need to go to the x-axis itself and actually see what those numbers are. So that would be this section right here. So -4 to 2 is your solution set. Does that make sense? So my answer is -4 to 2. Now, what if you were nervous about that? What if you thought, I don't know if that's actually right. Find 0 and test it. Find 0 on the graph, or, well, not find 0. Pick 0 and test it. As long as it's not one of your critical points, you can test it. Plug 0 in right here. I'd end up with -8 is less than or equal to 0. True or false? True. And 0 is in between that solution set, which means I have the right answer. All right, 2 more slides. I think, or 3. I don't know. The alternate approach. This is where, like I was saying, you could, if you do have, I think this is the exact same problem as before. It is. This is showing you that if you don't like the whole get everything to one side and just focus on where it is in relation to the x-axis, you could just enter the left side in y1 and the right side in y2, and then you could look at the inequality, and you would go to your graph and you would say, where is the y1 graph below the y2 graph, right? y1 graph is what type of curve? Look at the degree. It's a quadratic. And the y2 graph is what type of curve? It's linear. So looking at the picture, where's the quadratic lower than the linear? And that would be right here. Yes? If you like this approach, you would then have to, instead of focusing, this is why I don't go this route, because I like to just go with the x-axis. But in this case, you can't do, hey calculator, tell me the zeros, because the zeros are happening here and here, right? That's not our critical points. The critical points, if you go this way, are where they're intersecting. So you would have to do second calc intersect, and then it's 3 questions, and you have to find this one, and you have to find this one, and then those would be, you would end up finding that that's at the x coordinate -4 and the x coordinate 2, which translates exactly to what we already have. So there's that approach as well. You decide which one you like. The algebra approach, the graphing shortcut is what I nicknamed it, approach, or entering the 2 and then checking where one curve is in relation to the other, and then doing intersect. Let's go to another practice problem. Here it is. How did I? No, you're good, you're good. Which way are you going? Why are you going that way?
So I can put this on your desk.
Oh! I'm sorry. I was trying to look at her notes to see what I caught. Alright, I gave you the graph. Okay. Go to the next one. I already gave you the graph. Ignore the graph for a second. Let's refresh your memory on factoring when it's 2 terms. Remember, factoring with 3 terms, a times c, what are the multiples of this that add to this? When it's 2 terms, check for a GCF, and then just pull the GCF out. So this has a GCF of what? Of x. I'm going to make a note. Since it's 2 terms, check for GCF. Alright, so they have a GCF of x. I'm going to pull an x out. What would be left? X squared minus 1. I'm pretending it's an equal sign. Now you have something times something equals 0. Set them equal to 0 and solve. So we have x equals 0. X squared minus 1 equals 0. Be careful. When you're solving and you have to square root, you have to account for it. It could have come from the positive or it could have come from the negative, because there is an entire critical point there that you would be leaving off if you only wrote 1. So we have 3 critical points. Now you could go to y equals in your calculator. We're going to practice that calculator shortcut. We're going to go to y equals, we're going to type in x cubed minus x, and we're going to zoom 6 it. Now, here's where you've got to get comfortable with your graphing calculator. I don't like how far away I am from all that activity. There's a lot going on right here, and it's really, really, really small space. So let me introduce you to the zoom in feature. Zoom in is going to say, okay, I'll zoom in for you. It's going to ask you, where do you want me to center my window where I'm about to zoom in? And in this case, I'm just going to leave it right there and hit enter.
You didn't lose
I didn't hit it. What did I not hit?
You didn't hit the 2. I couldn't zoom.
Okay. Let me go back. Graph. Getting scared. Alright, zoom in. There we go. It's going to say, where do you want me to zoom in at? I'm going to say right there. And then now I actually can see better. Sometimes zoom in goes too far, and in that case you would either zoom 6, go back, or you would just adjust your window. Okay, we found 3 zeros. We found 0, yep. -1, yep. +1, yep. Right? Go back to the original. The shortcut was, where's the graph, what? Above the x-axis. So, above it. Literally, it's above it here and here. Yep. That's it. So my answer is going to have 2 intervals. Now you got to know what the intervals are. Well, imagine your zeros. This was -1, this was 0, and this was 1. So it's running from -1 to 0. Was it closed? No, it's open. I wish there was a factor. Alright. This was -1, this was 0, this is 1. Alright. So it's parentheses. It's running from -1 to 0, union with 1 to what? Infinity. Let me write that on the board, and then I'll go back and pull that up. That's it. What do you think? Seems really complicated, but it's just get your critical points, and then it's a matter of where you shape. Where's the graph, either above or below the x-axis? Let's do one more. I actually don't even have this one here. We're going to subtract everything over, and there's not a single like term, is there? So then everything's just coming over to the left. I am going to put it in order. So I want you to try it. Go to your calculator, type it in y equals. Make sure you get out of the exponents place. Don't type it in wrong like I just did. Alright, this is a 4th degree polynomial. I'm a little nervous this is going to be really big, but let's just zoom 6 and see where it is. Zoom 6. Okay, so it's not that bad. It's all right there. You can't see the bottom, but I don't really need it, because remember the shortcut is you're just seeing where's the graph above or below. What you need to know are the x-intercepts, the zeros. So this is where on your paper I would just sketch this curve. I'd leave some room so it's not too crowded. I would sketch the curve. Yours is different. Oh, when you subtract it over. So it's going down, coming up, bouncing. All right, so we put this in black. Oh my word. Let me get it. All right, there's mine. Okay, so we're coming down, bouncing up just after. There we go. Okay, so I need to know what this is. I need to know what this is, what's happening here. Something's weird. It's either crossing in two spots, and I can't see it, or it's bouncing off of it, and I need to know this. So now it's going to be second count. I'm going to go ahead and find that far left one, because that one has no ambiguity to it. So second count, tell me the 0. I need the cursor to be left, which in this case is above. Then it needs to be to the right. Then it's going to say, now guess. So I'm going to put it as close to it as I can get. So that's -1, 0. That one's pretty. Alright, so on the paper I would say that this is -1, 0. Or if that bothers you, putting the 0 there, then just mark that it's -1. If that bothers you to have it written as a point, because you're fixing to do interval notation, I don't want you to confuse, like if I wrote -1, 0, I don't want you to confuse that as the answer solution set. So maybe just write the -1. Now I need to know that one. And I have no clue what's actually going on there. So what would be a smart idea here? Zoom in. Let's zoom in and see if that's crossing or bouncing. So I'm going to hit zoom in, and it's going to say, where do you want the cursor? I'm going to move the cursor right over there. I need it to zoom in right there. I need to know what's happening. Okay, now I can see it's bouncing. And I say this because there have been graphs before where when you look at it, it looks like it's bouncing, and then you zoom in and you see there's an ever so slightly crosses over and then comes back, so there's actually 2 there. I needed to make sure that wasn't happening. So, now I'm going to repeat. Second count, find that 0. Let's go left of it, right of it, and on it. Here's where you need to be familiar with your decimals. 0.6 repeated. 2/3. Think about it. 0.3 repeated is 1/3. Double it. 2/3 is 0.6 repeated. So this is right here. 2/3. Now I need to find that last one. And in this case, now I'm in a situation I can't even see the last one. You can fix that by hitting zoom 6 again, and it'll just go back to that original window. Now I can find that last one. So second calc, find the 0. Where's the cursor? There, oh, there it is. Left bound, right bound. Guess won't even get close to it, but as long as your left bound and right bound are obvious, then the guess is okay, it'll work. Okay, we got 3.414. We're going to go to the nearest. What do they usually make you do? 3, right? So 3.414. I would not expect you to know that decimal off the top of, or that fraction off the top of your head. Okay, now, remind yourself the shortcut. Where's the curve? What? Below the x-axis. Okay, so that's here and here. So now you're going to shade in your line, like you're going to say, okay, so it's running from here to here, and then it's also running from here to here. So does the 2/3 matter? No, because it's also closed. Now, whoa, let me back up. Does the 2/3 matter? Maybe that's not the right question. Check the note to yourself if it was open or closed. Because if it was open, what would you have to do on the 2/3? You'd have to skip over it, right? So it does matter in the sense of you have to pay attention to, was this open or closed? Had it been open, then you would have to say, I'm skipping over 2/3 to finish the rest of it. But since it's closed, then it's irrelevant. So -1 to 414, and it's closed. That is 4-6. I removed like 9 problems from 4-6 homework because they were the part that's not on the exam. So the 4-6 homework, I took out number 2, number 5, number 12, 13, 14, 15, and 16. Yes. Oh my word. Oh, never mind. Wait a minute, it's here.